Okay, everybody can hear me. Hello, everyone, and welcome to this presentation on themes, styles, and more. I'm Cyril Mottier, so at Cyril Mottier on Twitter, and I'm the product engineering lead at Zenly. By the way, we are hiring, so if you're looking for, we are looking for Android engineers, loving challenges. So if you are that kind of engineers, please feel free to ping me after this talk, or come to see me. So I'm going to go quite straight to the point here, which is themes, styles, and more. I wanted to start this presentation with a screenshot of my blog. It's actually a screenshot I took like this week, but it's actually an article that I wrote 8 years ago. It was on 2010, and at that time I was speaking in French, and I was also writing in French because I was afraid of my speaking skills. I'm not afraid anymore, but my English is not better. But what I wanted to show you here is that actually, contrary to what Romain said, actually themes and styles are from the beginning of Android. So it's been 8 years, and themes and styles have been around for more than 8 years. So we're going to talk about XML actually today. I know that it's not trendy. Everybody talks about architecture or Kotlin, all of the trendy stuff, but we're going to talk about XML. So I'm sorry for that, really. Before deep diving into styles and themes, I think there is one point that is necessary to understand. I don't know if you're familiar with AAPT. So AAPT stands for Android Asset Packaging Tool. And it's basically the building tool that reads through your XML files, so your Android manifest, your layout files, and obviously your styles file, and compile them into a binary format so that it can be bundled inside your APK. And we're going to talk mainly about AAPT2 because there is 2 versions of it, and the second version is actually the one that you are probably using nowadays, mostly because it's the default now. So if you're up to date on your Android project, or if you're creating a new project from scratch, you will be using AAPT2. So let's deep dive into styles and themes. And styles and themes actually are kind of the same thing. They are actually the exact same thing, especially when it comes to definition. So when you define a theme or style, you will use the style XML tag. It's the mother of all, obviously, as I said, but it's an XML tag that will be used to define a set of attributes. In particular, it's kind of the equivalent, the XML equivalent to a map in Java or Kotlin. So it's a key value store with 0, 1, or more pairs. So let's look at an example. Here, I have a style, so defined using the style XML tag. And then I have an attribute called name that contains actually the name of this style. So in that case, list item. And as you can see, by convention, normally your style should be upper camel case, and you will see in the next slides that it's actually more than that. It's normally a dot-separated list of upper camel case ports. And then you can have inside 0, 1, or more key value pairs. And a key value pair is defined using the item XML tag. Once again, an item XML tag has a name, which is the name of this key value pair. So here, in that case, Android min height. And then the content is actually the value of this key value pair. But actually, I'm talking about key values, but when you're talking about styles, you're not really talking about keys. You're talking about attributes. So there are 2 main differences between keys and attributes. First, this difference is mainly because we are in the XML world. And when you are in XML, when you attach some data to an XML tag, most of the time it's called an attribute. And secondly, because attributes are a little bit more than just keys. In particular, in Android, an attribute can carry format type information. We will see later what it means. It can belong to a namespace. And finally, it can hold some optional constraints. So let's first look at the format types of an attribute. So when you have an attribute, by default, its type is any. So any means whatever, everything, basically. And by default means that when you don't define a type, it's any by default. But then you can define a type to an attribute. And those types are actually split into 2 main parts. two main groups. The first one is called the resource types. So as you may have guessed, these types are actually exactly the same as the one that you can use in the Android resource mechanism. Okay? So you can declare a color, a string, an integer. So the only difference here is that there is this is actually the same XML tag that you will use to define this resource, but there is two main differences. First, for a dimension, you will use the diamond XML tag, but actually when you want to declare the format type of an attribute, you will have dimension. And when you want to declare a Boolean in the resource, you will use the bool XML tag, but the format type is Boolean. The rest is pretty straightforward, is always the same. I don't know the exact reason between this difference. I guess it's legacy or something. Please ask the Android engineers. I don't know. And the second group is called special types. So special types are, well, not resource types. In particular, you can have three kinds of special types. The first one is enum. So when you declare an attribute as an enum, it will contain only a value from an enumeration, and this value is mutually exclusive from the other values. If you want to combine some values, then you will use the flags format type. And the flags format type will be the best example, I guess, on Android is gravity. So you can pass, for instance, right, pipe, top, and this is a flag attribute. And just one quick and funny note here is that there is a difference between Android Studio and AAPT. So if you use Android Studio will autocomplete with flag with no S, but it doesn't compile. And if you put an S, Android Studio will tell you that there is an error, but actually AAPT is requiring you to use the flags with an S. So the correct format is flags with an S. And finally, the third special type is called reference. So reference is basically a pointer to a resource type, to a resource, sorry. So for instance, @layout / my layout or @string / my string. So one little drawback, I would say, using reference is that you don't have a type associated to it. So when you say that an attribute is of format type reference, you don't know about the actual type referenced. You don't know if it's a string or layout. Then we said that an attribute belongs to a namespace. So by default, when you're using all of the Android framework attributes, they all belong to the same namespace. And this namespace is defined using this particular XML namespace definition. So I guess you're probably familiar with it because it's at the beginning of all of your XML files. And it defines, so this is by default typed by Android Studio, and it defines the Android namespace. So whenever you are having this XML namespace definition, when you will use an attribute from this namespace, you will have to prefix it with Android : one funny note here is that you can use whatever you want. It's not mandatory to use Android. You can use whatever name you want, but please stick to the convention because it makes your project easier to understand. And the rest of the attributes, so the one that you're actually creating on your own or importing from some libraries, are part of a global namespace. And this global namespace is defined using, once again, an XML namespace definition. So by default, it's quite long, and it's actually schema.android.com/apk/ normally your package name. But doing that can be tedious, error-prone, and sometimes it doesn't work because with build flavors and build variants, your package name may change. So the correct way to do that nowadays is normally to use res-auto so that the tools can replace it dynamically at compile time. And if you want to, well, not type this long sentence or this long line, you just have to type app-ns in Android Studio, and it will autocomplete in this namespace definition. Once again, here you can use whatever you want. It's not mandatory to use the app name as a namespace, but if you stick to app, it's better for other developers because they will be able to understand. So now that we know about format types and namespace, let's look at the definition of an attribute. So an attribute is defined using the HRA XML tag, and then you have a name, which is mandatory, of course. You can't have an attribute without a name. Here, in that case, it's background, so this is extracted from the framework. This is how the Android column background is defined. And then you have the format type. So as I said, it can be a list of types. So here I'm saying that the background is actually a reference or a color. And this is quite useful because it will enable the system to do some type conversion. So for instance, when you're getting a drawable here on the background, if you have a color actually, it will be converted to a color drawable internally, automatically. And as I said just before, we can have also some constraints. So for instance, on the integer format, you can put some constraints like min and max, basically upper and lower bounds. And this can be quite useful because it may actually trigger errors at compile time. So if you try to use the month attribute with, I don't know, 20, for instance, you will have a compile time error because here it's not in the lower, between the lower and the upper bounds. Another trick that you can use with attributes is actually something used internally for instance, the layout width or layout height. So by default, when you use layout width, you can pass whatever dimension you want, but you can also pass wrap content or match parent, and this is because it is defined this way. So we're telling APT that layout width is actually a dimension or an enum. And enum, inside the enum, we define all of the possible values. And this will actually works as auto-completion. This is also used by constraint layout to be able to pass either a reference ID to a subview or parent, right? So actually, all constraints in constraint layout are actually either a reference or a string, and this or an enum, which is actually a string whose value is parent. And all of these attributes are actually part of this huge class that you can find in the documentation called r.attr. And in this page, you can find actually all of the attributes defined by the Android framework. We will go through all of them, not all of them, but some of them during the presentation. So let's wait for more info about it. I wanted to end on attributes using just looking at the conventions. So especially the naming conventions. It's in particular important if you create your own attributes. So by default, when you create or when you use an attribute, you will see that it's always lower camel case. So here, there are some attributes from the Android namespace. It's always lowercase. There is actually always exception to rules or to convention. And there is two main exceptions. The first one is for layout attributes. So when you have a layout attribute, you will prefix it with layout underscore and then use lower camel case. And the second exception is for state attributes. So states are used like in state list drawable or state list animator or color state list. And in that case, you will prefix them with state underscore, but then you don't use actually lower camel case, you use snake case, right? So as you can see, state drag overed is really not like the regular convention. So these are actually the two main exceptions, but there is actually two other exceptions. And you know that rules are meant to be broken. So I'm just showing you that, but let's look at why these exceptions have been made, actually. It's okay to break the rules, but if you do that, please do it cleverly. So the first exception is actually constraint layout. So if you look at the attributes from constraint layout, you will see that it starts with layout underscore, which is good because it's a layout attribute. But then you may have sometimes some attributes, some underscores in the attributes. And that's because actually constraint layout comes with a bunch of layout attributes. And it's always easier to kind of namespace them. So this is actually a clever use of a clever break of the rules that improve readability and ease of use. And the second exception is actually something that is deprecated, so it's just here for the node. It's analog clock, so if you've been developing on Android 1 to 1.5, maybe you know about it, but now it's deprecated, and the attributes from this widget was actually not following the convention. So now that we're done with attributes, what can we do with styles? Well, styles, as I said, is just a bag of attributes, but actually a style can inherit from another one. And the default syntax for that, to define a parent to a style, is to use the parent XML attributes. So here, my style, called Style Wars The Last Jedi, is actually Style Wars. But as you may have understood, AAPT knows that the parent of a style is obviously a parent, so you can get rid of the style slash. One funny note here also is that you can use question mark instead of the @ It shows an error in Android Studio, but AAPT is completely fine. It passes completely fine. But please don't use it, because it's like, I don't know, maybe for legacy. And here, once again, you have an @ which is actually not necessary, because AAPT knows that you're pointing to a style. So you can remove it. And this is actually the best form you can use, because it's the shorter form. And it's called an explicit parent, because, well, you're defining the parent explicitly. But if you don't specify a parent, AAPT will try to look for an implicit parent. And in that case, AAPT will find the implicit parent to be style.wars. Why that? Because AAPT will actually just use the name of your style up to the latest dot of your style. So the parent is actually the name up to the latest dot. So in that case, style.wars. Two gotchas about parenting. First, if you want to have a parent who is not in your namespace, you have to prefix it with the namespace. So here, I have a theme card nano style, which has a parent called Android theme material.light. So here, I'm prefixing it with Android : So I know that it's not really useful nowadays because of app compat, but if you want to use framework resources, you will have to do that. Obviously, if you have a parent which is in a different namespace, you can't use implicit parenting. So you have to always have explicit parenting with namespace parent. And finally, because of the implicit parenting that AAPT does, if you want to have no parent, you have to be explicit about it, actually. Because if I don't put the parent, then the implicit parent here would be style wars. So if you want to have a style whose parent is nothing, then you have to specifically put empty as a parent. This is called parentless style, right? So in general, when you're defining styles, always try to use the shorter form. So first, if you don't have a parent, just use the no parent form. If you have an implicit parent, if it's possible to use implicit parenting, use implicit parenting then. And finally, if implicit parenting and no parent doesn't work, then maybe it's good to have the explicit parenting, but use its shorter form, so without the @style slash. And that's basically it about styles. But we are on Android, and what are styles on Android? Well, a lot of stuff, because Android is really a universal style. There are plenty of them. There are styles, text appearances, themes, theme overlays, and actually all of them are actually defined with the style tag. So they're all the same thing. The only difference is how they are applied, to what they are applied, and what they contain as key values, right? So let's deep dive into those 4 styles and themes. So first, let's talk about style. So a style, it's the same name as the XML tag, but a style generally refers on Android to a bag of attributes that are used to style a view. So for instance, let's take this example. I have a TextView, which contains a bunch of code, but there is this block which is very interesting because generally this is the kind of styling that you do on all of your list item in a recycler view. So you want all your item in the list view to be of a minimum height, you want the background to be a list selector, and you want some padding, some horizontal padding and some vertical padding. So a good way here would be to extract that to a style and use that style so that you can reuse this style between your list items. So what you will do is just extract this block to a style. So you can do that by creating your own style, and you're done. When obviously you're using Android Studio, you can do that using the tool just by right-click, extract extract, and style. And it will actually create this style for you and replace the attributes by this style. Once you have this style, you just have to go back to your layout and replace this huge block just by the style definition. So you attach a style or you set a style to a view just by using the style equal @style / the name of your style. So in that case, @style / list item. And then you're done. This is really, really simple, and that's what a style is. Obviously, please reformat. So if you reformat, this is the kind of layout that you have. And then you can use this list item between your list items layouts. So it's really nice for reusability. Then I talked about text appearance. So a text appearance, once again, is a style defined with the style XML tag. But actually, it is applied only to a text appearance or text in the case of a text appearance span. And it contains only text-related values, key values, right? Here is an example. I have a text appearance whose parent is textappearance.appcompat. And as you may have seen, a text appearance, by convention, generally starts with text appearance dot. So it's a way to namespace your style into, well, their own namespace. So whenever I'm creating a new text appearance, please put them under text appearance. How can I use it? Well, actually, text appearance can be used in XML or in Java code. And this is kind of the only dynamic style on Android. What I mean by dynamic is generally when you use a style on Android, it's used only at inflation or constriction time. So you can't, for instance, create a list item as we saw before and set a new style to it. There is no set style on a text view or view. It is actually the only style that you can set to a text view and at runtime and dynamically change the appearance of your text view. So here, what I will do, I just retrieve a text view, and I just have to set text appearance on it. So maybe you know that set text appearance is actually only API 23, but there is a text view compat variant if you want. And you will probably notice here that the text appearance dot title is actually named in Java text appearance _ title, and that's because of the naming restriction that we have in Java or Kotlin. And text appearance can actually be used in one other case, which is named the text appearance span. So I don't know if you're familiar with text appearance span, but I guess there will be a talk about it tomorrow with Nick and Florina, so please go there. And a text appearance span is basically a span that will apply to the text all of the attributes from your text appearance. So here, I'm creating a text appearance span just by passing my text appearance style, right? So what can contain a text appearance? So a text appearance can contain all of these attributes. So as you may have seen here, those attributes are always character level styling. So there is no line height or anything related to the paragraph, right? Everything is related at the character level. So when you talk about text color, it changes the color of one character. That's the same for the text size and stuff. And there is actually 16 of them, and there is one that has been added in Android P called fallback line spacing, but we don't know if it's going to be in the final version of Android P, so I prefer not to talk about it. And there is one gotcha, once again, there is always a gotcha. It is when you're using a text appearance span. So when using a text appearance on a text view will read through all of these attributes, but if you use a text appearance span, only those attributes are actually handled and managed by the text appearance span. So please make sure you remember that. So basically, a text appearance span can handle the color, the size, and the typeface or the font family. But you can't apply a shadow or you can't apply text all caps to a text appearance span. It won't work. So if you pass a text appearance with text all caps set to true to a text appearance span, nothing will happen. It won't change anything. And finally, about text appearance, because we are setting a style, like a style to the text that can also have some style defined on it. So let's look at the precedence rules. So if you want to set a text appearance to a text view, you will use the text appearance attribute. And then you pass the style of your text appearance. And this is actually applied first. But then, if you have one, I don't know, text color or text size or whatever in your style, it will override what is defined in your text appearance. And finally, if you have in your layout text color, then the highest priority is here. So whatever you're doing here, the text will always be blue cerulean, regardless of what you have in your text appearance.title or what you have in your form header. There is actually a higher priority to that, and we've seen it just before. It's the text appearance, actually span, sorry. If you use a span on it, then it will be the highest priority. Then we go to another kind of style called theme. So a theme is, once again, a style defined using the style XML tag, but it is applied to an activity or a context in a more global way. And this is actually how you can see it. So if you look at the context API, you will see two methods. The first one is set theme, and the second one is the getter to this theme. And if you look at the set theme, it actually takes a style, which is a theme, and apply it to your activity. Please remember that, as I said before, themes and styles are, except text appearance, not dynamic, so you have to set it before inflation or before your views are created. So always call that before super.onCreate or before set content view or before any inflation of a view. So this is the way to do that manually, but hopefully there is one way to do that from XML using the Android manifest. So in the Android manifest, you can define the theme of an application just by using Android:theme. So here, I'm setting the application default theme to this application. So all activities from this application will use this theme. You can obviously, just one quick note regarding that. So this is actually calling internally set theme, so the method I've shown before. And this is done by activity thread, which is kind of the main in activity to run activities. And it is called just before calling the activity onCreate method. And here you're defining this at the application level. But if you want like a dedicated or a specific theme for just one activity, you can obviously change it on the activity tag. So here I'm setting a new theme, which is theme City Deluxe on the activity. I said that a theme is actually tied to a context, but the Android manifest allows you only to apply it to an activity or an application. The thing is, you can have a theme, for instance, on a service or a content provider or a broadcast receiver. You can do that. But it won't work if you put that in the Android manifest, because what you put in the Android manifest is only applied to activities, even if it's on the application. So if you want to have a theme on a service or a content provider, you have to do that manually. I know that most of the time it's not necessary because themes are very interesting in UI cases, but it may be necessary for you to be able to retrieve some values from the theme in your services and content providers, for instance. And if you want to do that, just call set theme in your application. So what can contain a theme? Well, a theme is like a huge bag of attributes. It can contain a bunch of different types of resources. It can contain colors, so colors that are mainly used to theme or to style your UI, like color primary or text color primary. It can contain information about your windows, like window background or window disable preview. It can contain some default widget style. So by default, all widgets from the framework have a default style. Like for instance, a text view will inherit from the text view style, or the progress bar will use the progress bar style. So it's always the name of the widget with style at the end in lower camel case. It can contain also some references to some drawables, stylable drawables, like the selectable item background, which is pretty useful when we have a list item in a recycler view, for instance, or the list divider. It can also contain some preferences style. So yeah, you know about preferences, the framework preferences. So if you want to change the framework preferences, you can do that using the theme. And it also can contain some text appearance, default text appearances, defined by the framework, but you can override them. And finally, there is a bunch of other resources like dialog theme or disabled alpha or whatever. So theme attributes can be referenced. The good point about theme attributes is that they can actually be referenced in your layouts and themes. So the idea is really to have like an indirection. So instead of using a hard color or a hard string, you can say, what's the current value of this color or this string in the theme? So let's look at an example. Let's go back to our style called list item. So we have an Android background set to @drawable/list selector. So it means that regardless of the background, regardless of what screen we are, it will always be list selector. So a good thing here would be to have like an indirection. So we will use this kind of syntax just to point to something called selectable item background, which is an attribute used in a theme. The rest stays the same because it doesn't change regardless, depending on the color of the background or on the screen. So the syntax of an attribute, of a theme attribute, is actually this one. So it always starts with a question mark. So question mark denotes like an indirection. It denotes a theme lookup. Then you have the optional package name. So in that case, I'm pointing to an attribute from the Android namespace. Then you have the type, which is always attrib. And then you have the name of your theme attribute. Once again, shorter is better. So we can reduce that just by getting rid of the attrib / because APT knows that you're always pointing to an attrib. And if you don't have a namespace, like for instance, when you're using color primary from AppCompat, you don't have to put the namespace because the global namespace has actually no name. A girl has no name. And you will notice that there is actually two color primary here. There is the one without the Android colon, so it's the one from AppCompat. And if you're putting Android colon, then you will use the one from the framework, which is only API 21 and above. So make sure to understand the difference between those two. So you will say, how can Android do this indirection? It's kind of magical. Well, actually, it is not magical. And everything happens in this method, which is called context obtain styled attributes. It takes 4 values, and these 4 values basically define your attributes from your layout. It defines what kind of attribute you want to read, which is href, and then a style or an attribute to this style. And this delegates to something called resources.theme obtain style attributes. And all systems widgets are using it, and most of the time when you're creating your own custom widgets, you will be using it so that theme automatically works everywhere, regardless of if it's a system widget or if it's a custom widget. And I highly recommend you to look at the documentation of it because it defines the precedent rule. So for example, it will inform you that when you define an attribute in your theme, it can be dangerous. So for instance, if you say in a theme, Android background is equal to red, then all views that have no background set on it will be red. So it's generally a bad idea to use background on theme, mainly because background is actually an attribute that is mostly used in styles, so to style a view, but not to style an activity. So this is good. I mean, themes are really nice, but sometimes you want to theme, or maybe you have like a one activity architecture, and having a theme that is applied to an entire activity is not really handy sometimes. So starting API 21, you can use something called theme overlays. And theme overlays are the exact same thing as a theme, but applied to a view or a view hierarchy, right? So it basically allows you to override the theme for a particular view hierarchy. And this can be done just by using the theme attributes in XML. So here, on this layout, I'm overriding the current theme, which is the one from the activity or the application, and saying that it's a theme overlay.bazinga, okay? One gotcha here is that it doesn't set the theme, it overlays the theme. That's why it's called a theme overlay. So all attributes that are not defined in your theme overlays will actually fall back to the theme. So if, let's say, for instance, I'm only changing the color primary in my theme overlay, then the rest of your theme attributes from your activity are still valid. Some notes about theme overlays. They're based on context theme wrapper, which is actually available starting API 1. but it's just a bag of theme attributes, so it always applied to a view, but it contains the exact same attribute that you can find in the theme, and it's propagated to descendants. So if you're putting it on a view container, it will be propagated to all of its descendants. And this is actually backported, so even if it's been introduced in API 21, it's actually available up to API 14 because of AppCompat. And this is gone because actually AppCompat has a different inflation path, so whenever it reads through the XML and see Android column theme, it will actually create or wrap your context inside a context stem wrapper. So I talked about compatibility. So all of this is good, but where can I use that? So as I said, theme overlays are available starting API 14. No problem using it on all versions of Android. I mean, for me, all versions means starting API 14. If you are going before API 14, there is no AppCompat anymore, so it's going to be difficult for you, and I don't envy you. Then, regarding theme attributes, the best way to enter that is that, and you know about that if you're a developer, it depends. It depends on where you're using theme attributes. So if you're using theme attributes in layouts and styles, it's actually available starting API 1, so you can use it with no problem everywhere. If you're trying to reference a theme attribute in a drawable, it doesn't always work. So it works, it's been introduced in API 21, so it will work perfectly if you're min SDK 21. But before that, it won't work at all, except for vector durables and animated vector durables, because, well, they've been backported. And finally, in color stateless, it's been implemented in API 22, but it's been backported thanks to AppCompat, and that has its own inflation path for color stateless, and so it's been backported up to API 14. So basically, using theme attributes everywhere is not always possible, but just remember that in the case of drawables, it's not possible before 21. So a lot of theory here. So let's look at some example in real life. In particular, theming is interesting with tinting. So let's look at this application, which is Zenly, the company I work for. So we have like a main activity that contains the panel on the right and also the one on the left with the map. And as you can see, there are some items that are really looking the same. So for instance, here you can see that a user is actually displayed the same way, so with an avatar, a title, and a subtitle. But there is a difference in color. So the only difference is that we have a different background, so we want a different color of the title and a different color of the subtitle. Here, once again, we have an icon, which is actually bundled only once in the application and is tinted just depending on the current theme of your hierarchy. And the list divider is the same. So how can we do that? Well, it's quite simple. We will use themes attributes. And in particular, when you go to the list item that displays a user, we just use the text color Zenly list item text color primary for the title, and for the subtitle, we'll use list item text color secondary. It would be also fine to do that directly in the text appearance, but we don't do that directly in the text appearance at Zenly, but it may be the case in the future. And then, if you go to the fragment dashboard for the magnifying glass, you can see that it has a background that is depending on the current theme, and the tint is also depending on the current theme. So I will tint this icon depending on basically the background color, right? And then I can go to the theme file and the theme overlays file. And you can see that it contains actually the exact same key values, the exact same keys, but the values here are the same, depending actually on the background. So I have a theme, which is the default theme, called theme.zenly, and then I have a theme overlay called themeoverlay.zenly.light. So it's basically a theme overlay that is only used on light backgrounds. Once I have that, what I have to do is just to set the theme on the container of all that hierarchy, and automatically I will have my list item icons and divider changed or tinted based on the current theme. We can go beyond that. For instance, we can try to, I don't know, I've done an example here, but it's not something that is available in the application, but I tried to do a night theme. And here on the right, you have the night theme, and on the left, you have the current theme. And the normal mode and the UI mode, the night mode, could be like very easy to do when you use theme overlays and themes in general. So by default, in the theme, we have a bunch of attributes that define the colors that we use. So for instance, the color background, the color of the list item title, the list item subtitle. And then we can have another theme that is put inside the values-night. As you can see at the top, it's not the exact same file. It's actually a file that is put inside the values-night so that it's going to be used by the framework when your device is in UI mode. Night mode. Here, the keys are the same, but the values are different, just based on the current theme. And finally, with AppCompat, you can apply that just by calling getDelegate .setLocal mode. And that's basically it. So I don't know if we have time, because I have a lot of content once again. Do you want to continue just on how to organize the themes, or? Yeah, okay, so there is a slide showing thank you, but it's not the end. One more thing, organizing styles. So I wanted to talk about that because I've been seeing a lot of problems with that. So there is a huge different themes, and I know that there is some issues organizing them. So let's deep dive into some ways to do that. So here I have an example. So I have theme.city, which defines actually 4 items. So as you can see, it has a parent, but here you will see that lint will actually display some warnings here because, well, you're using attributes that are not available on API 14. So it's only available starting 21. So if you are using these attributes directly in the theme, you will have a warning. So what people generally do is split the theme between values and values-v21. So you end up with that, which is fine, it works, but it's not perfect. Why? Because as you've seen, maybe there is actually duplication here. So the parent is duplicated between v21 and the values, but also the background, which is something actually available on all version of Android, is actually also duplicated. So whenever the designer or whatever you want to change the background, you will have to go to 2 files. And if you have actually another one in v23 or v24, then you will have to go to all of those files to change the color of your background. So you would tell me, yeah, but I just have to name a color like a background. You can do that, but then you move the problem further. Actually, a correct way to do that, even if it looks like weird or quite big at the beginning, it may be rapidly useful if you have a large project with a lot of styles and themes, just like I'm usually confronted to. So here is the main architecture that I encourage you to use. And this is actually the one part of the one used internally by AppCompat, because AppCompat is actually 4 level deep. So it's more difficult than this one. But the idea is to have always a notion of base themes and base v something themes. Let's look at what are those themes. So themes.cd is the theme that you will use, actually. It's let's say, the public theme. It's the root theme. And it always inherits from a base.theme.cd, right? So here, for instance, in values, I will have base.cd, base.theme.cd. In v21, I will have the exact same one. But these themes are actually only pointers to the current version. And they can contain, if you look at this diagram, you can see that all values that are defined, for instance, let's say in values v21 base.theme.cd, will actually be available for all versions of Android up to the next bucket. So if I put something in base.theme.cd in values v21, it will be available up to v22. But in v23, it won't be available anymore because I have a new theme. And then it inherits from something that is actually always valid in the current version of the API. So here I have base v1, which inherits from base v21, which inherits from base v23. So, and then finally you have your, I don't know, theme.appcompat. So I know that it's quite complex to understand, so let's look at an example. What does that mean, like if I'm on API 21, or 22, sorry. So the system will go through this hierarchy. So it will go through theme.cd, which inherits from base.theme.cd from v21, which inherits from base.v21.theme.cd, which inherits from base from v1.theme.cd. And actually, you will use that hierarchy to remove completely duplication. If I'm on API 26, this is what you will have. You will have another path, but basically you will have the exact same thing that you have on v21, except that you will also add what we have in the v23 here. And then v23 will have everything that is in v21, and then v21 will have everything that is in v1. So if we go back to our example, just to have something more clearer and simpler to understand, so we will create a v1. And in v1, what we want to put is basically the window background, because window background is available starting v1, right? So here I have base v1, which inherits from this parent, and then I have the window background set to it. And then I define this kind of pointer, which is base.theme.cd, which points to base.v1.theme.cd, okay? That's it for theme base. Then you have the one for v21, because here you can put everything that is available starting v21. And in that case, it's everything related to the status bar and navigation bar color. And finally, I changed the pointer for v21. Actually, the pointer will be v20. The pointer base.theme.cd will be base.v21.theme.cd. And this one actually points to here, and then the parent is v1, so we get back to the diagram I showed you before. And when you want to use, to declare your theme.cd in your theme file, then you don't have to do much. You just have to inherit from the base.theme.cd. So maybe you've seen that you may end up with a lot of styles, and that's why organizing them is pretty important. And I strongly encourage you to follow this, well, naming or convention. It's not something that is enforced by the framework, but I encourage you to do that. So for text appearance, always prefix them with text appearance dot, and put them in a file called textappearances.xml. So maybe you're not familiar with that, but actually APT enforces nothing regarding file names, so you can put whatever file name you want. And having text appearances in a text appearances file is nice. That's the same for theme. You prefix with theme, and you name the file themes.xml. For theme overlays, the file would be themeoverlays.xml. For widget styles, it's going to be widget.something, and then styles, put that in the styles widget. And for all the styles that are, you don't know where to put them, just put them in styles with no namespace. Obviously, the name is always upper camel case. And as I've shown, you may end up also by using this hierarchy with a lot of base theme. So I strongly encourage you to put that inside a dedicated file and a dedicated namespace. And this namespace is just base dot the namespace of your style, and then the file is textappearance_base or theme_base or, well, style widget_base. So just by doing that, you will split your themes and style into several files, and it will be very, very helpful for you and for your colleagues to understand what's actually this theme. Sorry, I think I've taken a lot of time, so thank you very much for attending this session. And if you have any question, I don't know if I have time. I don't have time, so thank you very much, and I will be in the booth at the entrance if you have questions. Thank you very much.